Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists where I make quick turnaround videos to help people during the coronavirus outbreak. So if you'd like a video, let me know and I'll help you out if I think I can. So today I'm talking, following a comment I got below one of my videos from, I think this is Ciara, I think that's how to pronounce it. She or he was looking at my video. Actually, it's called Intro to the Prime Number Theorem, famous theorem in number theory. I've actually got another video, just to be clear, which goes into the proof of the prime number theorem, intro proof, prime number theorem. This one here is really just an introduction to the actual theorem, what the actual statement of the theorem says. So we have pi of x is asymptotically equivalent to x on log x. And Ciara was asking about this log. To explain a little bit more, which I'm happy to do, for those of you that are familiar with logs, you might, if you haven't studied at university, you might find the second part of this interesting, because at uni, logarithms are done in a slightly different way to at school. So the school, what do we teach at school, broadly speaking? Logarithms, logs are the reverse of raising to a power, or what we sometimes call exponentiation. So 2 to the 3 equals 8, and therefore the log of 8 to the base 2, in other words, what power would we have to raise 2 to get to 8? Well, it equals 3. What's another one? What's, say, 10 to the power of -2 equals 0.01, so that's 1 over 100, and therefore the log to the base 10 of 0.01 equals -2. Okay, so that's good. What's introduced at school often is this concept, the natural logarithm. So it's at school, it's given the we denote it by ln, the natural logarithm, and that's log to the base e. And here, e is this number that is about 2.71828 ... It's a nice university exercise to show that e is irrational. The number e is irrational. Now, this seems a bit silly to have this focus all on this number e. Why? Well, I'm going to encourage you to have a look at my video. I think it's the second most viewed of my videos, something like 250 or 300,000 views. The number e is everywhere. And this is just a nice way of, in 10 minutes or so, seeing how this number e here, this number e, comes up in a whole lot of situations in real life. Truly fascinating. If you're interested more in the mathematics behind this video, then I've got a follow-up video called The Making of the Video E, where I go into the mathematics of all that. Okay, so I think that's all I wanted to say about school. So if we go back to the prime number theorem, we have this x on log x, or x on log to the base ex. So hopefully now you can understand, Ciara, how this log works. And obviously this is a number, log x, x is a number, if you for a variety of x, you can feed in x into this, and you'll get a number out when you divide x by log x. Okay, let's talk about the university approach, which is a little bit different. Oh, actually, just before I go on, why this fascination with all of it? Why this fascination with all these logarithms? I mean, what's the point? And so I'll just find logarithms used to multiply and divide for calculators. I know for some people it's hard to imagine a situation when there weren't calculators, but there were before about something like 1970. You couldn't use calculators in exams. At that stage, what people would use is, so use log, being logarithm tables. So there were tables that you could use that would give you the logarithm of numbers. Or if you're more in an engineering sort of practical situation, you might use a slide rule. So if people are interested in this, I'm happy to do a follow-up video on that. But I'll just leave it at this point, and I just want to talk about university or college. What's the situation here? Well, here we do things a little bit differently generally. So part of the problem, well, one way to motivate this is if you look at y equals x squared, it's very easy to work out using integration the area under the curve. And similarly with y equals x cubed, that would be no problems. Y equals x to the 100 on 3, that's not going to be a problem to integrate. Similarly, y equals 1 on x squared is easy to integrate. Y equals 1 on x to the power of 2.85 would be easy to integrate. There's one problem child, and that is this one, y equals 1 on x. Because when we try and integrate that, we can't integrate it in the normal way. I'll leave you to explore that. But the fact is that if we've got the graph y equals 1 on x, well, you can actually work out areas. The area does actually exist under the curve. So what mathematicians did is they said, well, log x, so this is log to the base e, can be, it can be the area from 1 to x of, 1 on t dt. So here's the graph t. This is here, this is y equals 1 on t. So this is 1, this is x, and we've worked out the area. And in particular, e, that number e we said is special because I'll draw it first. This is 1 on t, here's t, here's 1, here's e, and this area equals 1. There's only one number, this special number e, that gives you an area of 1. Now, once you've developed log here, you can then, all the rules that you learn about at school for log flow, flow from that easily. So, log x, y equals log x plus log y. That just follows from the properties of integration. Just finally to wrap up, which I did say in that first video that Ciara was talking about, intro to the prime number theorem. In number theory, which is a branch of mathematics, when we say log x, well, that means a log to the base e, which is the same as log. So in number theory, if you see this, as you do in the prime number theorem, it actually means this log. I suppose I could put x there and x there. It actually means the natural logarithm. Okay, I think that's all I wanted to say. If you've got any questions on this, let me know. Otherwise, any questions on any aspect of mathematics, comment or email me, and if I think I can help you, I will do so.